today I want to speak on merely expressive devices. And what I mean by that is a linguistic part of a sentence. So it's something in language such that the part plays a role in determining what proposition is expressed by a sentence, like the sentence A. So it has a proposition determining function. But what it doesn't have is it doesn't play a role in determining the truth conditions of that proposition, box A as it were, thereby expressed. Okay, so it helps us to determine a proposition or a thought, but it doesn't contribute to the truth conditions of that kind of thought that it helps to express. Now you might wonder, is there a thing like that? Does it make sense even to drive a wedge between propositions and truth conditions of propositions? The quick shot at merely expressive devices is to refer to logical operators. Okay, so take a disjunction symbol. I want to claim, and later I'm going to back that up in the course of the talk, that something like the disjunction symbol is a merely expressive device. Okay, so we use disjunction. That's something linguistic, something symbolic in language, natural language or formal languages. And these logical operators like disjunction, they help us to express a proposition or to grasp a thought. For example, the proposition that A or B, the proposition that is expressed by a disjunction, but they do not at the same time represent anything in the world. Okay, so when we then look at the truth condition of such proposition, the proposition expressed by the disjunction A or B, it's not that there is anything in the world out there that would have to correspond to the disjunction symbol in the language. Okay, and that's a difference from the other linguistic symbols that are not merely expressive devices. Okay, some of them help us to express a proposition and then they refer to something in the world. Disjunction only helps us to express a proposition and doesn't do anything beyond that. That's why it's a merely expressive device. Okay, and this is nothing new in the sense. In fact, I think of that as the classical account of logical operators. So if you think of Wittgenstein in the Tractatus, he would say, mein Grundgedanke ist, dass die logischen Konstanten nicht vertreten. So his basic thought is that the logical constants don't represent. Okay, and that is roughly what makes these logical operators merely expressive devices. Now, what I want to do in the course of the talk is to make all of that a bit more precise, and I will do that by building things that I call conceptual frameworks. Okay. So these are structures of the form that you see here if you follow my mouse pointer. Okay, so a conceptual framework, in my sense, will consist of a purely mathematical part and something else that involves typically empirical objects, right, in the physical world, maybe. Okay, and the idea will be, once I've built such a conceptual framework, then we'll be able to look at sentences like this A here. And in the framework, the sentence A will express a proposition, a thought, and that will be a set of possible worlds. So this is the set here. So it's an intentional system that I'm building. But these possible worlds, don't think of them, as a kind of Lewisian worlds or something like that. Rather, they are purely mathematical objects. Okay, the whole part here is a mathematical structure of purely mathematical possibilities. Okay. And then these worlds that are in there will have a definition of when they count as actual. And roughly the idea will be a possible world here, these purely mathematical entities, they will count as actual just in case they are isomorphic to the intended interpretation of our language, to the things out there in the world that we want to talk about. Okay, so think of the worlds here as mathematical entities that can be labeled by an intended interpretation. And if you put these mathematical possibilities and the labeling together, you will get what I call a conceptual framework. And then if you look at merely expressive devices like the disjunction symbol, such a symbol might occur in the A, right, in these sentences. And thereby, okay, the or symbol has a contribution to make. The contribution is it helps us to determine the proposition that is expressed by sentences with, say, the disjunction symbol. Okay. And the contribution that it makes to determine that proposition will be purely mathematical again. Okay, so roughly again, the idea is that this disjunction symbol has something, a semantics to it, but it's purely mathematical. It never reaches sort of into the world. It stays within the purely mathematical realm of my frameworks. Okay, and once this is done, we have a proposition. And then for the question whether that proposition is true, the disjunction symbol will not have to play any role whatsoever anymore. That's why the disjunction symbol will be a merely expressive device. Okay, so that's roughly the idea. Now, what I want to do now is build such an intentional and conceptual framework semantics, apply it, and draw some philosophical conclusions from it. I will not give you a definition of the term conceptual framework, although, you know, in principle, something like that could be done in a fairly general way, but I'll give you examples, okay? So this is a bit like, you know, Tarski defining truth for a concrete object language rather than defining true for variable L. He gives you sort of a paradigmatic way of building a truth definition for specific paradigmatic object languages. And I'll do the same here. That's my methodology as well. And my first example will indeed be logical constants. My second example will be defined terms, stipulatively defined terms. Okay? According to my reconstruction, they will also turn out to be merely expressive devices. And then finally, and that's more surprising, I hope, I'm also possible to reconstruct metaphysical syntactic items, like metaphysical modalities, in my framework so that they become merely expressive devices. So you can also think of metaphysical terms as merely expressive devices. And then I'll draw some general conclusions, amongst others about conceptual engineering. But the upshot of the whole talk will be that some of the tenets of Carnapian logical empiricism can, I think, be vindicated, at least to the extent to which they are dealing with merely expressive devices. Okay? So, and overall, I have this kind of a bigger project that I want to write a book on, or I'm in the process of working on it, where I try to revive logical empiricism. Okay, but this is just between, you know, us here. So don't tell anyone because people then won't like me anymore. Okay, so unofficially it's part of that revival. Okay, officially, no. I mean, I only want to, you know, save Carnap on a very specific domain of these weird things called merely expressive devices. That's all. Okay, has nothing to do with logical empiricism. Okay, so let us build a framework. The way to do it is we start purely mathematical. We start by building a purely mathematical structure. These are these possible worlds. Okay, I'll continue to call them like that. And in my first example, let's say these worlds are triples looking like this: a D set, an M1 set, and an M2 set. Okay, where D is just a finite non-empty initial segment of the natural numbers. So D could be the set, you know, 1, 2, 3, 4, for example, purely mathematical. Okay. And M1 and M2 are subsets of D. So M1 could be the set 1, 2, 3, and M2 could be the set 2, 3, 4, for example. Okay, nothing has happened as yet. We just built a set of worlds. Each world is a triple like that. Okay, and here we run sort of combinatorially through all the possibilities, assuming that, you know, M1 and M2 are sets of natural numbers, and D is also a finite set of natural numbers. Then we add the second component to this purely mathematical part of the framework, which I call the label structure. And that is roughly what our thoughts are meant to be about, or what our language is intended to talk about. Okay, I call it a label structure because it's a bit like you have an unlabeled graph and then you label the nodes with something. Okay, and here we label them, say, with empirical entities, as you're going to see. Now, the label structure in this case will consist of 3 sets: humans, men, married. Okay, where humans is just a set of humans, men is the set of men, and married is a set of married humans at some point in time. Okay, could be now, could be in the future, could be in the past. Okay, we fix a time, then we get these sets, we stick them into the label structure, and that's what you have. And then you put the set of worlds and the label structure together, and you get an F here, and that's one of my conceptual frameworks. Okay, so very, very simple. Roughly, the idea will be, in the mathematical part, the D set will correspond to the set of humans. The M1 component of a world will correspond to the set of men, and the M2 component of a world will correspond to the set of married people. Okay, so the world we roughly have there representatives of, you know, humans, possible humans, as it were. Okay, and men at that world, and married people at that world, and so on. Okay, but there is just one label structure out there in the world, and we want to think or talk about it ultimately. Okay, the next step is we define what it means to call a world. Remember, these are these purely mathematical triples, actual in the framework. Okay, and we say a world is actual in the framework. Everything is framework relative here. Okay, actual in the framework, just in case there is a function from the domain of that world, that's the set D, into the set of humans, which is a structure preserving map, meaning it's bijective, 1 and 1 and onto, okay? It's a correspondence. You line up sort of the members of D, these natural numbers, and the humans in a one-to-one fashion, okay? And it's structure preserving in the sense that M1 corresponds structurally to the set of men and M2 corresponds structurally to the set of married people. The world is actual in the framework if it gets the structure of the intended interpretation of the intended labeling right. That's the idea, okay? Now, as it happens in our framework here, it's perfectly fine to have more than one world as actual, but we're going to see that each of these actual worlds, they will be pairwise isomorphic to each other, okay? So up to structure, as it were, there's just one actual world, okay? Now, as usual in intentional semantics, we will call a set of world a proposition. It's an intentional semantics, okay, that we're building. Well, strictly speaking, what we really want to have is we will call a subset of W, a set of worlds that is closed under isomorphisms a proposition, okay? So this is a bit more demanding than what you normally have in intentional semantics, okay? But for most purposes, you can forget about that, okay? Just use your standard lingo that you know from intentional semantics. The idea that propositions are the things, sets of worlds, as it were, closed under isomorphisms on a structure preserving map, that's an idea that is out there in measurement theory. And I can tell you more about that if you're interested, okay? And then we call a proposition true in the framework, just in case it includes a world that is actual in the framework, okay? So roughly one of the worlds in the proposition saves the structure of the intended interpretation that's out there in the world, okay? So again, this is a familiar thought from the non-statement view of theories in the philosophy of science. So I'm taking components in theories that are out there and combining them in my, what you will see, sort of quasi-Knapian manner, okay? But that's roughly the idea. So here's an example. Let's move at a very early point in time, beginning of times. You know, it's fictional. You get the idea. So back then, the set of humans, right, was a small set, just Adam and Eve there, okay? And the set of men at the time, that's just a singleton of Adam. And then the married people are Adam and Eve. So that's not even theologically correct now, okay? You know, but you give me that, okay? Adam and Eve both count as married at the time, okay? So that's the set. And then you can run through the worlds, okay? So some of these worlds, they have as their domain the set of natural numbers 1, 2. Others have higher cardinalities, okay? But they're set, if you take the set 1, 2, and you put the 1 here and the set 1, 2 there, then that world actually has the same structure as the intended labeling here, okay? So basically 1 corresponds to Adam and 2 to Eve, and then the structure of the sets you get right. So that world counts as actual in the framework, okay? And then there is an isomorphic one. There 2 plays the role of Adam, as it were, and 1 of Eve, just the other way around. It's still actual, and they are isomorphic to each other, okay? But if you take the world W3 that I have here, where sort of the thing that is a man, Adam, is the only thing that's married, that's not actual. There's no structure preserving map from W3 to the intended labeling, okay? And neither for W4, okay? So these are not actual. And then if you take this proposition here, W1, W2, it's true in the framework because it includes an actual world, whereas the proposition W3, W4 is not true. Okay, so we define truth for propositions directly here. And then if you take the set of all triples D, X, Y here, okay, then this is another true proposition where X is non-empty. Why is it true? Because it includes, for example, that world here, W1, and that's an actual world, okay? And the set of all worlds whatsoever, W, is also true. And now here's the first thing to observe. If the framework as a whole, that is capital W, the set of all worlds in the framework, taken as a whole, does not constrain the labeling structure. Basically, some world in the framework must get the labeling structure right up to isomorphism, okay? Because we have run combinatorially through all the possibilities, okay? The only constraint is, well, D is finite, okay? Because we have only finite domains, okay, in our worlds, okay? And non-empty, but give me that, okay? Other than that, we run through all the possibilities. Therefore, we can say by math alone, and of course, the definition of the framework, capital W is true in the framework. There must be an actual world in it because we've run through all the combinatorial possibilities, okay? In contrast, that the set W1, W2 is true, that's due to the framework and the facts, okay? because W1, W2 does not include all possible worlds in the framework. Okay, that's to do about, that's to do with what the intended labeling structure is like. Okay, that it consists of two people at the time, and one of them is a man, and so on and so forth. Okay, so you get the idea. Some propositions are true just in virtue of the framework, because we've run through all the possibilities, really mathematical possibilities. And some propositions are true, well, they don't include all the combinatorial possibilities. So their truth must be also not just in virtue of the framework, but in virtue of what our thoughts or language ultimately is about the label structure. Now, the final step is we add language to the conceptual framework. So for example, take a first order language. We've got unary predicates for man and being married, okay? And at a world, the idea is that D, the domain of the world, is the range of the quantifiers. So for all X means all things in D at a world, okay? And the interpretation of the predicate man is M1, the second component of this triple. And the interpretation of the married predicate, the unary predicate in my case, is M2. And then we can define in the standard way a sentence is true at a world in the framework by means of the standard semantic rules, okay? We use W as a model, as it were. So it's just an intentional semantics in the usual sense. And we say that a sentence expresses a proposition, a set of worlds, if this is precisely the set of worlds at which the sentence is true. So we get the usual correspondence between sentences and propositions as in intentional semantics. And then we define truth for sentences in terms of truth of the propositions expressed by the sentences. So as sort of old-fashioned philosophical tradition would have had it. Okay, so we don't define truth for sentences directly in Tarskian manner, but we say a sentence is true if the proposition it expresses is true, and that we've already defined in terms of actuality, which we've defined in terms of the existence of these structure preserving maps. And then in our little example, we get the obvious. So for example, the sentence "there is a man" is true in F. Okay, it's true in the actual world, as it were. Okay. The set of worlds expressed by the proposition, that's not the set of all possible worlds. There are some possible worlds at which there are no men, okay? There is a man or there isn't a man. That's true at any world in the framework. The proposition thereby expressed is a set of all worlds, okay? And that proposition we've already determined is true just in virtue of how the framework is set up, okay? Whereas that there is a man is true, that's not just true in virtue of how the framework was defined, but also, as it were, in virtue of the facts out there that concern the labeling structure. And now we can drive a wedge between some kinds, one kind of linguistic symbol in our language and another kind, okay? So for example, take the predicate man or what it expresses. At a world, it's the M1 component that represents the label, the set of men, which figures in the truth condition for propositions, okay? So if we introduce the notion of a concept now as an intentional semantics, roughly a function from worlds to extensions, then we can say the concept of being a man in our framework represents man, its label, which figures in the truth conditions for propositions. Okay. Once we've added the language, we can say the predicate man, this unary predicate, expresses the concept of being a man, which represents something, namely the set of man, its label, which figures in the truth condition for propositions. So the predicate man has a double role to play. It contributes to the expression of propositions, and it also helps us to determine the truth conditions for propositions. Okay, it does two things simultaneously. Determine the proposition and tell us, look at that thing out there in the world, namely the set of man, okay, as you can see from the truth condition. And that is why the predicate man is not a merely expressive device. What it does goes beyond merely expressing propositions. However, now contrasted with disjunction, there is no coordinate for disjunction in any world. Okay, one can again, as in intentional semantics, introduce the notion of a logical concept, okay, which is a truth function, or it takes two propositions and then maps them to their unions or something like that. Then you can say that the concept of disjunction does not represent anything that would figure in the truth condition for propositions. Okay, there's nothing in the truth condition that corresponds to disjunction or the concept expressed by disjunction. Once we've added the language, we can say that the operator, the symbol, expresses the concept of disjunction, which in turn does not represent anything, any label that would figure in the truth condition of propositions. So that is the operator, the logical operator for disjunction has just one role to play. It contributes to the expression of propositions, but it does not contribute additionally to the truth conditions of the propositions thereby expressed. Okay. Of course, it's true that disjunction expressed by that the proposition expressed by A or B is the union of the proposition expressed by A and the proposition expressed by B. Okay, that's true, but that's all in sort of the purely mathematical domain. Okay. Once we get to the truth condition for propositions, for sets of worlds, it's not the case that we have to compare the truth function for or the union function for propositions to any label that would figure in the definitions of actuality or truth. That's why the disjunction symbol is a merely expressive device, okay? And that's why I've built a framework where we can clearly separate these two roles. And when something like disjunction just has the one role without the other, we call it merely expressive. So the upshot is, in the framework that I've built, logical concepts do not represent, and logical operators are merely expressive devices. So with a little bit of more lingo, we could say they express concepts, but they do not represent properties out there in the world. And by that, I mean any of these things that you find in the label structure, okay? They don't reach into the world. That's the Wittgensteinian thought again. And now you might think, yeah, Hannes, sure, that's because you've built such an odd framework, yeah? But I don't regard it as an odd feature, but rather a good model theoretic reconstruction of how logical operators work semantically, even in natural language, okay? The tradition would have said logical constants are syncategorematic, okay? And that's very close to what I have in mind when I say that they are merely expressive devices, okay? So I'm going with the tradition, but just try to make it a bit more clear what the tradition meant with that, okay? If you deviate from that, then that's the odd framework, as it were, okay? Now let me change our framework a little bit. Second example, okay? Second example. Let's go beyond logic, yeah? Now what I do now is I beef up my little framework, my F from before, and turn it into an F prime, okay? And make it slightly more complex, slightly more interesting. And I only tell you now about the changes. So I turn these triples that have been our worlds into quadruples now by adding a fourth component, okay? And this fourth component, this BZ at this world, say, okay? Basically, I determine from the other components, okay? I take D minus M2, so the complement of M2 with respect to D, everything that's in D that's not in M2, and then I intersect it with M1, okay? So it's the things that are not M2 and also in M1. That's my BZ. At each world, I compute B from the other components in that way, okay? But my worlds are strictly speaking now quadruples, which have this fourth component, okay? And now you might think, oh, okay, B is going to represent something in the world, but actually that's not the case, okay? So I put here in my label structure just a red asterisk. The red things are the new bits, okay? The rest you already know. And the asterisk just reminds us, it's a mnemotechnical device that reminds us, it signals that the B coordinate here will not be labeled at all, okay? You don't have to compare it to anything in the real world, as it were, okay? Now you might, a lot of nail biting, I hope, on your side. What could be B? What does he have in mind? It's something that's not M2. Remember, M2 stands for married, okay? And M1, it must also be M1. This stands for being a man. What could it be? Okay, I leave you nail biting, but the secret will be, you know, resolved very soon. Now I put these things together and I get F prime. That's my new framework. Okay, again, not much has happened. And now we define actuality again. And you can see here no changes. There is no B component here referred to by our truth condition. We leave everything the same. The B component here does not represent anything in the world, okay? Now, the rest I leave the same as well, okay? We take over all the previous definitions of actuality and truth, again, the framework does not constrain label, okay? Because again, we run through all the combinatorial possibilities that have been labeled, okay? We don't run through all the combinatorial possibilities with respect to the B component. But the B component is not labeled anyway, okay? So therefore it does not impose, as it were, or express a constraint on what is labeled because it is not itself labeled, okay? If B was labeled here, then we would now impose a constraint, okay? We would say, well, you know, what labels the B set must relate to the D, what labels the D set and the M1 set and the M2 set. as expressed by this little equation that we had before. But since B is not labeled, there's no constraint thereby expressed, okay? And now we add language, and now big secret revealed, it's the bachelor predicate, okay, as you might have guessed. So sorry for the example, but if it's about defined terms and analyticity, you're sort of legally required to give that example, okay? So we add a unary predicate of being a bachelor, as it were, to our first order language, and we reformulate all the standard definitions. Of course, the interpretation of a world, at a world of the bachelor predicate is just the B set at that world, obviously, okay? And then as before, there are men, okay, is true, but not just in virtue of the framework, but also in virtue of the labeling structure, the facts, okay? But, a logical truths, they are still just true in virtue of the framework. And in addition, what we get, if you look at this sentence here, for all X is a bachelor, just in case X is unmarried and X is a man, X is an unmarried man, okay? That universally quantified equivalence also expresses in the framework the set of all worlds in the framework. And we already determined that the set of all worlds in the framework, okay, is just true in virtue of the framework. Hence, that sentence is true just in virtue of how we define the framework, not true in virtue of the facts. Okay, so we get additional sentences now in the framework that are true just in virtue of how the framework has been defined. Okay. Now, if we introduce the notion of concept again as intentional semantics, we can say that the concept of being a bachelor does not represent anything that would figure in the truth condition for propositions, okay, because it's not labeled. And once we have the language, we can say that the predicate bachelor, this unary predicate, expresses the concept of being a bachelor, which in turn does not represent anything, any label that would figure in the truth condition for propositions, okay? That is, again, the predicate bachelor in that framework, okay? In other frameworks, it might be different, but in that framework, the predicate bachelor only contributes to expressing propositions, but does not contribute to the determination of the truth conditions for propositions, okay? It is true that you get certain equations, right? The proposition expressed by that is identical to the proposition expressed by that. But that's all in the purely mathematical part, okay? And how, no part of that equation figures in the comparison with the label structure, okay? So that's why the predicate bachelor is a merely expressive device, okay? The concept of being a bachelor does not represent, and the predicate bachelor is a merely expressive device. It expresses a concept, but it doesn't represent a property out there in the world, okay? And again, you might say, yeah, but that's just because of the second stupid framework, Hannes, okay? But I would say no. If you think of sort of a language, as it were, in which the predicate bachelor has been stipulatively defined from being unmarried and man in the way suggested, then in that framework, the defined term is indeed a merely expressive device, okay? Tradition would have said stipulative definitions are true by convention, okay? And that's what you get here. It's just, there's nothing fishy about that anymore, okay? So the meaning of bachelor in that framework is given by the meanings of married and man ultimately, okay? The primitives, married and man, these predicates, they are, not merely expressive devices, but bachelor is, okay? It's, as it were, a shorthand that helps us in a convenient way to express propositions, okay? But it doesn't do anything more than that, okay? The primitive terms, they do more than that, okay? And now you get the idea. We can also define a sentence now to be analytic in the framework, just in case. The set of worlds, the proposition that is expressed by the sentence in that framework is the set of all worlds. And since we only build conceptual framework in the sense that we run through all the combinatorial possibilities with the set of worlds, that's a good reconstruction, I want to say, of analyticity as the tradition understood it, okay? Logical truth, for example, analytic in the framework here, as is for all X, X is a bachelor, implies X is an unmarried man, and the like, okay? So in that framework, you get a good reconstruction of analyticity in the same way. Analogously, you can take that idea now and take it from analyticity and, bachelor to analyticity, merely expressive devices, and other predicates. So for example, okay, one thing that I always, wondered about, I'm interested also in theories of truth, okay? And, many people interested in conceptual engineering are interested in truth. Kevin is an example, but there are others, okay? Carnap is an example, okay? So a paradigm case example for Carnap of explication was Tarski's explication of the truth concept, okay? Now, what I always wondered about is this, take a disquotation about truth, okay? They say things like, well, the truth predicate is, it helps us to express propositions, okay? But, it doesn't refer to a property out there in the world. Or it doesn't give us anything more than being a device for expressing propositions, okay? It doesn't have additional explanatory power or the like. These are things they say, okay? Now, yeah, I can build a framework. I've not done that here, but I hope you got the idea. Where, for example, in the domain, you put natural numbers as codes for sentences, okay? And then you have at each world the set of sentences true, codes of sentences true at that world. And you build that truth component from the other components in a Tarskian manner, okay? So you build into the framework a kind of Tarskian truth definition, okay? In a typed manner, so there's no worry here about paradoxes, okay? And then what you get is you can use in the object language the truth predicate to express propositions, to grasp thoughts, okay? Maybe, depending on the rest of the language, you can thereby express propositions that you couldn't express otherwise, okay? Or even if you could, you might not be able to express these propositions in a similar convenient manner, okay? So I think in the same way as I've done it for being a bachelor here, I can reconstruct this quotationalism about truth. Okay, what they mean is that the truth predicate is a merely expressive device, and I can make that precise in an analogous manner. Okay, whereas if you think that the truth concept represents something out there in the world, okay, it will not be a merely expressive device anymore, and I'm going to reconstruct it differently. Okay, like I did, for example, with the predicate of being a man. Okay, so this quotationalism about truth, that's another application of what I'm building here. Now let me give my third and final example. Okay, so this is a bit different. So we need to reset things. Okay, this is not a slight variation, but we build a new framework. But I presuppose, I promise analogous definitions of actuality, truth, and so on. So I won't rehearse them again. Now, what I do now is I fix the set of objects, the domain, as it were, at the world to be one and the same set throughout the worlds. That's something I can also do. Why not? So the domain of a world will now always be very simple. It will be the set of natural numbers 1, 2. Just 2 objects at each world. Now, this is going to leave open what these objects are going to stand for, as you will see. Now, the worlds will be quintuples now, where 1 and 2, these are just the objects that are in the domain. So I have, as it were, distinguished individuals that I put into my worlds. Okay. It's like in mathematics. Some mathematical structures have distinguished objects, like the 0, for example, okay? In the field of real numbers has a distinguished function, and that's why you put it as a distinguished object into the structure of the real numbers. And I do the same here. 1 and 2 will be very specific in what they are doing. And then I have 2 sets, and here they will be binary relations. M and C will be binary relations on the set D at the world, okay? And I'm going to presuppose nothing for M, as it were, but for C, I'm going to presuppose that C is a reflexive, symmetric, and transitive relation, and in fact, what's called in logic or mathematics a congruence relation. So basically, it's something like the formal counterpart of an identity or equality relation, okay? If 2 things like 1 and 2 here are congruent at the world, then the world cannot distinguish between 1 and 2, even in terms of the M relation, okay? So for example, if 1 would stand in the M relation to itself, 2 would also stand in the M relation to itself if 1 and 2 are congruent, okay? So it's like the identity relation, as it were, at the world, okay? And I built in the formal properties of the identity relation, but that's all. And now there's another new feature of this third framework that I'm building. I now add what the friends of modal logic or possible world semantics for modal logic would call an accessibility relation, okay? And it's not sort of strictly within a world, but all the worlds taken together, they get another mathematical component that lives in that purely mathematical part of my framework. And this is an R relation, an accessibility relation between worlds. And actually here I'm defining it explicitly. I say W1, okay, sees or can access W2 with respect, W prime with respect to R, just in case, well, they have the same identity relation, as it were. The C relation and the C prime relation for these 2 worlds, they coincide. They're the same relations. Okay, so give me that for the time being. That's my accessibility relation. Okay, and now what's lacking still the label structure. What's the thing that we want to talk about or reason about? Okay, well, it will be the morning star, evening star example. So again, we are legally obligated to bring up that example. So that's what I'm doing here, okay? So my label structure will be a set here, the set consisting of MS and ES. What's MS? Well, it's the last body to be seen in the sky before sunrise in the period between the beginning of the year to mid-March. It's the morning star, okay? And then ES, that's the first body to be seen, you know, blah, blah, after sunset. Well, it's the evening star, okay? So you might think, why is he writing things up so complicatedly here? We already know, right? We have astronomy on board. The morning star is identical to the evening star is identical to Venus. So it's a singleton set here, okay? But what I try to do is here, I write up the definition of my framework in terms that would have been available even to the astronomist who wouldn't have known at the time that morning star equals evening star equals Venus, okay? So I don't want to give you the impression that I build sort of empirical knowledge into my framework. That's not what I'm doing, okay? The same framework, okay, can be used to reconstruct talk or thought at a time at which there wasn't empirical knowledge as yet that, you know, Venus equals morning star equals evening star. That's the idea, okay? And then I have the morning star here and the evening star here, okay? And then I have a move pattern. So that's a relation, a set of ordered pairs of D and D prime, okay, in this set here, in the singleton set, really, as we know, okay, such that D and D prime sort of stand in a sort of movement pattern, okay? For a certain time of the year, D emerges, and then for a different part of the year, later, D prime emerges. Again, and then a bit later, sort of, you know, in the next year, beginning of next year, D emerges again. And then again, a bit later, D prime emerges again. So it's the movement pattern of morning star and evening star, okay, this kind of oscillation. If two objects stand in that oscillating relation, okay, then they will stand in that movement pattern relation that I put here. And that's, as it were, the real movement pattern relation, okay? Now, really, we know that Venus stands in that movement pattern to itself, okay, because it appears, and then later it appears again, and then it appears, and so on, okay? And then I put the identity relation here for objects in that singleton set, okay? And then I put an asterisk here, and the idea will be that the R relation that is in the purely mathematical part of the framework will not get labeled at all. Don't think of the R relation, the accessibility relation, the modal part, as it were, okay, as representing anything in the world out there. It's just labeled like being a bachelor, as it were, was before. Okay, so that's my framework. I put the two together and I get my framework. The only new thing is really that we have an accessibility relation here. And then we define actuality in the obvious manner, no surprises, structure preserving map. In this case, I'm going to build into the structure that 1 really is labeled by the morning star and 2 is labeled by the evening star. And the outcome will be there won't be two distinct actual worlds that are isomorphic to each other. There will be just a unique actual world, really. And notice in that truth definition, there is no labeling and no structure preserving map check for the R relation. That's what I meant before. Okay, there is no labeling for R. R doesn't contribute to the truth condition for propositions ultimately. And again, I run through all the combinatorial possibilities of what morning star and evening star out there in the empirical labeling structure might be like, because I run through all the possibilities in my mathematical part. Okay, the only thing that I build into it, strictly speaking, is roughly that identity of morning star and evening star has these logical features of being a congruence relation and reflexive, symmetric, and transitive, and so on. Okay, but you know, think of that as kind of like the logical laws for identity, which we are happily presupposing in first-order logic. Okay, so it's not a real constraint on what identity out there in the world is like for morning star and evening star. Okay, so again, by math alone and the way we've defined the framework, there must be an actual world in the framework because we've run through all the possibilities. It follows that from what I've set up here, that there is just one world that is actual in the framework, and that's this one here. Basically, 1 and 2 need to count as identical, okay? And they, you know, 1 and 2 stand to each other completely in that movement pattern relation. Well, because morning star equals evening star, and that thing, the Venus, stands to itself in that movement pattern relation. And structurally, that's the world W1 here, and that's the only actual world in the framework. All the other worlds, they get something wrong, okay? And now again, you have propositions. For example, this is the proposition that we would informally in natural language express by the morning star and the evening star. They instantiate this movement pattern, this periodic movement pattern. okay? Because it's the set of worlds in which 1 and 2, that's the representatives of morning star and evening star, they relate to each other as given by M by the movement pattern. Okay, so that's a set of worlds. Then there is the set of worlds that I have here. That's what we would express in natural language by the proposition expressed by the morning star is identical to the evening star. Okay, I say that 1 and 2 stand in the C relation to each other. And then we also have propositions that we would informally think of as involving necessity now. And that's my idea, okay? So you would want to say maybe that it's necessary that the morning star is identical to the evening star, okay? And you can do that here by collecting the set of worlds W such that if you take all the W primes that are accessible through R from W, the proposition B, that's the identity of morning star and evening star, that proposition up there is true at W prime that, you know, is accessible from W here. Okay, so B is true at all the accessible worlds accessible from W. You collect all the little W's, you get a proposition, let's call it NB, the necessity of B as it were. And then it follows that all of these three propositions are true in the framework. Okay, and in each case, the proposition is not the set of all worlds, but a proper subset thereof. Hence, the truth of that proposition, okay, is not just due to the framework, but also to the facts. Okay. In contrast, here's an example. Take the complement of the B set here. Okay, so this is identity of morning star and evening star. Union NB. Okay, that's the set of all worlds as you can compute. So its truth is just due to the framework, to the way we define the framework, not to the worlds, because we've run through all the possibilities, through all the worlds in capital W. Okay. Now you might think, what on earth is that? That's not B or necessity of B. Think of a material conditional that's roughly if B, then necessary B. Okay, so that's the Kripkean law. Okay, it's this thing here. So if you add language with the corresponding predicates and with a necessity operator now, and you have the standard truth condition via the accessibility relation as we have in possible world semantics, you get that these three sentences are all true, but they are not analytic. So for example, A equals B is true in the framework, and A equals B, it is necessary that A equals B is true, okay? But they are not analytic because they don't express the set of all worlds whatsoever in the framework. However, the sentence, if A equals B, then it's necessary that A equals B, that expresses the set of all worlds in the framework. It is analytic, okay? And you know, indeed, it's one of the laws of, as it were, Kripkean modal logic, as it were, okay? So you get what we want. And the upshot here in that framework is that the concept N, okay, does not represent, doesn't have a label that would figure in the truth condition for propositions. And the syntactic operator box is a merely expressive device, okay? It expresses the concept, roughly the concept N, but it doesn't represent the property out there, okay? Because the R component was not labeled by anything in the intended interpretation, the labeling structure. And now you might think, yeah, that's really a strange framework that you're building, Hannes. And again, my reply is, no, it's not, okay? I think it's a nice model theoretic reconstruction of how maybe metaphysical operators might work semantically, generally, okay? And then again, you might think, yeah, you make the same mistake again of the old logical empiricist, right? You reduce metaphysical necessity to analyticity or so. No, I'm not doing that, okay? So the box here does not express analyticity. Here's an example. Box A equals B is true in the framework, but A equals B is not analytic in the framework, okay? So why is box A equals B true? Not because A equals B is analytic, it's not, okay? It's because the actual world only sees worlds in which A equals B is true. But what the actual world is not just a matter of the framework, but also what the facts out there are like, the labeling structure, okay? So that box A equals B is true is not just in virtue of the framework, it's in virtue of the framework and the facts. The Kripkean law from before, that's analytic, okay? So we get a nice frame relative reconstruction of the Kripkean claims, okay? But still, box is a merely expressive device, okay? And now, you know, I could beef that up, and I can in the Q&A if you're interested in that. So if I now add subjective probabilities and so on, I can even reconstruct Kripke's additional claim that the astronomists believe in box A equals B is a posteriori, okay? So I can reconstruct in my framework all the Kripkean claims, okay? And to the best I can see, all the claims that he makes, say, in naming a necessity, okay? So all of that can be reconstructed in a framework like that. And still, the box operator is a merely expressive device in the framework. Now, you can use the same idea also, again, for other cases. So metaphysics is interesting, okay? If I had a project on reviving logical empiricism, then clearly the status of metaphysics would be interesting to say something about, okay? But again, I'm not doing that, okay? But say you have something else in mind. You always wondered, what did people in general philosophy of science mean when they thought that, you could be an instrumentalist about theoretical terms in science, or even maybe a special brand of structuralist about theoretical terms in science, okay? Now, here's my answer. In a similar way as I've treated now the metaphysical operator, necessity, you can also treat theoretical terms in science. And if you do that in that way, theoretical terms will end up being merely expressive devices. That's what they had in mind, okay? They would only help us to express propositions. Again, if you're an old-fashioned instrumentalist, the proposition will then be just, about the observable part of the world, as it were, okay? But you don't even need to buy into that, okay? You could be an instrumentalist without that particular emphasis on observability, okay? In any case, if you're an instrumentalist about theoretical terms in science, what that means is you think of these theoretical terms as merely expressive devices. They help us to express propositions, but they do not represent any properties out there or relations out there in the world waiting for us to be discovered, okay? Now, if you're not an instrumentalist about theoretical terms, that's also fine, okay? Then they will not be merely expressive devices in my reconstruction anymore. So that's fine. There are many conceptual frameworks available for you. Some might be more useful for certain purposes than others, okay? Some might be useful to reconstruct instrumentalism if you want to be an instrumentalist. Some might be useful to reconstruct, being non-instrumentalists about theoretical terms and so on, okay? My strategy is just to offer them to you. That's what I'm doing here, okay? So you can make instrumentalism about theoretical terms more precise. And actually, trust me, there is a lot more than that you can do with that, okay? You might even think, moral terms, okay, as merely expressive devices, abstraction operators for neologicists as merely expressive devices, maybe all mathematical terms as being merely expressive devices, okay, which is again a form of logicism. So if I wanted to be a logical empiricist, that would be neat, right? If I could be a logicist again, but again, that's not my project, as I said, okay? So let me draw some conclusions and then I'll finish, okay? So I've built 3 frameworks for merely expressive devices, okay? I think of these frameworks as successful reconstructions of existing thought or language, okay? Remember Carnap's criteria on explication, right? You want to check whether what you get after explication is at least similar to what you started from before explication, okay? And I want to claim there is this similarity here, okay? So there were patterns of usage out there in my 3 cases that I captured in my framework, okay? What the framework does above that is, I think the framework, so using the framework clarifies, precisifies, and systematizes pre-theoretic thought and language. So that's exactly what linguistic frameworks were meant to do for Carnap in his work, okay? So Manuel mentioned the Stanford Encyclopedia entry that Andrei Karus and I wrote. We early on introduced the role of linguistic frameworks that linguistic frameworks played for Carnap throughout his career. Okay, so if you're interested, have a look there. Okay, my conceptual framework are sort of, I think, improvements over the Carnapian notion of linguistic framework. In each framework, the total underlying set of worlds is a purely mathematical construction, and is true in the framework by math alone. I mean, by math and how we set up the framework. Okay, if you want to support its truth, argue for its truth, accordingly, you don't need empirical evidence. Okay, so what then determines which framework to choose for certain purposes? Well, since there is no epistemic component left anymore, the set of all worlds in the framework must, by math alone and definition, include the actual world. There couldn't be epistemic reasons anymore for choosing a framework for a certain purpose. What remains is purely pragmatic reasons, okay? Being useful, being for certain practical purposes, being simple, and so on, okay? Framework choice is purely pragmatic in my notion of framework, and that's what Carnap was advocating famously in empiricism, semantics, and ontology, okay? If it wasn't like that, my frameworks would be proper theories, okay? But they are not, they're purely conceptual. And in each of the 3 examples that I've built, the merely expressive devices that I've reconstructed in the framework, they might either enable us to express propositions or make the expressing of propositions more convenient, or both. Okay, and the merely expressive devices don't do more than that in these frameworks. That's why they are merely expressive devices. Okay. Now, in example 1, the logical operators were the merely expressive devices. Now, what about intuitionistic OR? Well, you know, in my drawer, I have other frameworks for you available. And one of these frameworks is an intuitionistic framework. And there we would have an OR operator again. And again, it would help us to grasp a thought, but it would do so differently from the classical OR in the classical framework that I've built before. Okay, but still also the intuitionistic OR would be a merely expressive device. Okay, and we can choose, we can revise, all of that is in our power. Okay, in framework 2, we have had an example where stipulatively defined terms such as bachelor are merely expressive devices. But, you know, I can define other terms, and again, I get merely expressive devices. And what counts as a defined term in one framework might not count as a defined term in another framework. Okay, so that's like, think of a textbook. Okay, what is a definition in one mathematics textbook on continuity of real valued functions? What counts as a definition there in a different textbook is a theorem, but not the definition. Okay, so sort of depending on the textbook, okay, something might be analytic or something might be sort of a mathematical theorem. Okay, and you get the same idea here. What is analytic in one framework might not be analytic in another framework. Okay, analyticity is framework relative. Whether a term is merely expressive, that is framework relative in my reconstruction. Okay, and again, there are lots of frameworks available. And analyticity, truth in virtue of meaning alone, as it were, is perfectly clear, precise, and unproblematic in the frameworks. Okay, it might have lots of problems if you apply the analyticity predicate to names of sentences in natural languages. Okay, so Quine had a point there, I would say. But analyticity in my frameworks, okay, I want to claim is completely unproblematic. The analyticity of this bachelor law, as it were, it doesn't reflect some intrinsic feature of the sentence anyway, but rather how bodies of information are organized in the underlying framework. Okay, so sort of, you know, the bachelor information is organized and interweaved with the meritness and man information in the framework because we've built the framework in that way. If it was built differently, then this law might become, you know, an empirical law, but it's not analytic in the other framework anymore. Okay, that's how I think of analyticity. And in framework 3, we've reconstructed sort of Kripke's claims. Okay, as I said before, and this preservation of Kripke's claims is compatible with the necessity operator still being a merely expressive device. Okay, and now, you know, I can do the same with all the other claims that Kripke gives us. And in that way, I can give you a whole Kripkean story that is compatible with the box operator still standing for metaphysical necessity and being merely expressive at the same time. Okay. Now, for conceptual engineering, especially Carnappian explication, the consequences are this, I think. Okay. Now, first of all, you've seen that in the reconstruction of these merely expressive devices, their meanings do not have worldly components. Okay, there are no labels for them. Another way of saying it is the merely expressive devices, their meanings are purely structural. They live purely in the mathematical part of the framework. So if you want to get control over the meaning of merely expressive devices, you only need to get control over that structure, okay? That structural contribution that they make. And I want to say that you can get control over that structure, that structural meaning, as it were, that the merely expressive devices have in my frameworks. How? By making, okay, that structure explicit and then assess it, and if you want, change it, revise it. Okay, how do you do that? Well, with the help of rules like semantic rules, or definitions like the definition of being a bachelor that we built into the framework, or as it were, axiomatic constraints like the constraint on the accessibility relation in my third example, such that all of these things, rules, definitions, and axiomatic constraints, you can reconstruct in this plurality of conceptual frameworks that are available for you, of which I've just given you 3 examples. Okay, and if you do things correctly, okay, the corresponding terms, okay, over the meaning of which you get control, okay, These terms are still merely expressive devices. Their meanings are purely structural. And hence we get a handle on them in the way that I've described, by rules, by definitions, or axiomatic constraints, okay? So what this means, I think, is that at least for merely expressive devices, there are good reasons to believe that there is no serious lack of control challenge. You know, that challenge that people like Hermann Kappelan and others have brought up to conceptual engineering. Well, maybe it would be really good to do conceptual engineering, but we lack control, okay, for various reasons. Some of them are to do with semantic externalism and so on. I want to say that as far as the conceptual engineering of merely expressive devices is concerned, I don't think that there are big worries about lack of control, okay? And in fact, other than arguing from a reconstruction, I could argue from examples that can be reconstructed in the way that I've suggested. So I think that it's not a mere coincidence that the best examples of Carnapian explication, as he describes it in the first chapter of the Logical Foundations of Probability, they concern merely expressive devices, okay? So for example, the explication of logical concepts by rules, by semantic rules, maybe proof theorists would say by, you know, inference rules and so on. That's a good example of an explication in Carnap's sense. And as I said, the logical concepts or the logical symbols, they are merely expressive. Or, you know, an example that Carnap himself mentions, the explication of truth that Tarski gave, okay? As I already said, again, I want to think of that as the explication of, you know, the meaning of a merely expressive device. Or the explication of mathematical concepts. I mentioned continuity before, okay? By definitions or axioms, okay? We have lots of examples in the history of mathematics, which I want to say is conceptual engineering, okay? Continuity in the original sense, like, you know, it's a function that you can draw by not lifting the pen from the paper, to continuity defined in the epsilon delta way that you learn in high school, okay, or early on in your math studies, okay, to continuity in the way, you know, in topology theory, you define continuity in topological spaces, okay. All of that is sort of an explication that improves the previous explication, and so on, of the pre-theoretic notion of continuity for functions, okay? You get better all the time. And in each case, you can reconstruct what you get in the way that I've reconstructed, for example, being a bachelor in my second example, okay? Or the accessibility relation that I've added, which satisfies some structural constraints in the third example, okay? So overall, I hope I've shown that I've constructed a sort of improved quasi-Carnapian account of frameworks, analyticity, explication, and merely expressive devices. Surprisingly, the account can even be extended to metaphysical concepts. So that's something that I think Carnap, at least for a good time of his career, overlooked. Maybe not the later Carnap. And the whole account also explains why conceptual engineering, I think, is feasible, definitely feasible for merely expressive devices. So some of the tenets, at least, of Carnapian logical empiricism are vindicated, at least to the extent to which they were dealing with merely expressive devices. And I would never claim more than that. Thank you.